my name is Anvita Gupta, and the title of my talk today is Mind Blown by Mindstorms, LITAS and My Journey in STEM. So the computer and I have always been close. In fact, you might say I grew up alongside the computer. When I was just a few months old, my dad would put me in my car seat, put the car seat next to his computer, and start working. He would make sure to rock me back and forth every once in a while when I cried. And at 3, I would sit on my dad's lap and play Connect the Dots on his massive Linux computer, which you can see here. But I never thought of computer science career-wise, not that I didn't think of careers at that age. At 4, I wanted to be an actress. Upon learning a few years later that actresses generally didn't make a lot of money, if you weren't a good one, I decided that the diva life was not for me and changed my career decision to be a pediatrician instead. This aspiration lasted for about 10 years and was, I believe, the root of my interest in biology. In fact, I didn't think of computer science career-wise until A, I found out it took 14 years to become a pediatrician, and B, I completed my 10th grade science fair project. I had decided to enter only a month before the deadline, but I didn't want to do a project on anything but experimental biology. And as any experimental biologist can tell you, it takes a lot longer than a month to do anything in experimental biology. And I didn't even have a lab. So I turned to my childhood friend, the computer, to help me out of my procrastination-created fix. In search of a project that I could do independently, I learned that researchers computationally study gene expression levels to find cancer biomarkers, proteins that signal that a tumor is growing in the body. I didn't understand why anyone would want to target cancer biomarkers with drugs, as these researchers were doing. It seemed rather to me like turning the fire alarm off while the house was still burning. I had been taking graph theory in an after-school mathematics club, and the mix of graph theory and biology swirling around in my mind inspired me to take a different approach. I decided to rank proteins to target with drugs through their protein-protein interactions. Basically, I found that just as a researcher would market to the person with the most, or an entrepreneur would market to the person with the most friends, because that person has the most influence in their network, researchers should target proteins that have the most protein-protein interactions, because they have the most influence in cancer networks. With this project, I won 4th place at the Intel International Science and Engineering Fair, and published my work in Harvard's peer-reviewed Journal of Emerging Investigators. However, what really impacted me the most was seeing that every person who came to my project had a friend or loved one die of pancreatic cancer, or they themselves were survivors of a different cancer. I was drawn into the interdisciplinary world of bioinformatics or computational biology by the intoxicating knowledge that I, a high school student laboring over my laptop, could have a tangible impact on someone's life, that I could make the world better through whatever I created. I never looked back. From there, I took AP Computer Science, took online courses in machine learning from Stanford, and learned a total of 8 programming languages. In my future science fair projects, I focused on drug discovery. So it currently takes about 10 years and $5 billion to bring a single drug to market. And a lot of the reason for this is the process that researchers currently use to find drugs. They take thousands and thousands of chemical molecules and pipette them against a protein of interest in a process that is both a brute force approach, is extremely costly and laborious. My idea was to use artificial intelligence to create a software program that could predict beforehand which drugs would work, thus reducing the time and cost of drug discovery and bringing treatments to the market in a much faster manner. So there was only one problem with this approach, and that was that the proteins for each disease were different. So in essence, I would have to make a different software program for each disease. I coded one algorithm to discover drugs for dengue in 11th grade, but I was still in search of a more universal solution. This appeared in the summer of 2014 at MIT's Research Science Institute, when I was introduced to intrinsically disordered proteins, or IDPs. IDPs change shape constantly, unlike other proteins which you find in your cell, which have a set 3D shape in order to function. Because IDPs change shape, they're able to bind to multiple different proteins in the cell, and this makes them extremely important in cellular processes such as reproduction. When an IDP becomes mutated, it leads to a host of different diseases. For example, 70% of proteins are IDPs, including P53, which you can see here, as are proteins in Alzheimer's, tuberculosis, and even 5 out of 7 proteins in Ebola. As you can see here, this is a map of all the IDPs associated with breast cancer, pancreatic cancer, and ovarian cancer, which I built using a database I created. These proteins in the middle, these IDPs, are involved in all 3 cancers, and one of these is P10. So IDPs like P10 make extremely attractive drug targets, but the problem is we don't currently have a way to target these IDPs with drugs because they're changing shape. And how do you find a molecule that will bind to something that's constantly changing shape? So my solution was to create a drug discovery program that would look for drugs that mimic segments of these IDPs that actually don't change shape. In this way, you can kind of trick the other proteins in your cell into binding with the drug instead of binding with the IDP, thus treating the disease and blocking the IDP from functioning. I applied my method to discover new drugs for diseases such as cancer, tuberculosis, and Ebola, and I identified 4 novel therapeutics for tuberculosis that have been tested in preclinical trials in China. All 4 of these drugs have been found to be active, and this is really exciting because there hasn't been a new tuberculosis drug for the past 40 years. So for my research, I won 3rd place in the Intel International Science and Engineering Fair with a Medal of Distinction in Global Good. I was a national award winner in the Siemens competition, and I also received the Global Healthcare Award in the International Biogenius Challenge. I had the honor of presenting my research to President Obama at the White House Science Fair, and I was also invited back to speak about my work at the White House Ebola Innovator Summit. It has been an incredible experience and one that I never could have predicted even a few years ago. But on this journey and at the highest levels of the science fair circuit, I noticed something conspicuously lacking. Where are all the girls in technology? I get a lot of questions from parents nowadays on how to teach their kids to code. It's not well known that in the first robotics club I joined in 7th grade, I was relegated to putting together the presentation while the boys did the coding. I was pretty angry about it afterwards. After all, I had joined the robotics club, not the PowerPoint enthusiast fan fest. But that experience, along with my natural stubbornness, led me to take a summer camp in robotics. And when I won 2nd place in the entire camp, I put the club from the previous year out of my mind. In fact, I didn't think about it again until I took AP Computer Science, and 3/4 of the girls dropped out of the class, as compared to less than 1/4 of the boys. And what really surprised me was that the girls dropping out had higher grades than the boys who were staying in. I read Sheryl Sandberg's book, Lean In, and I found out that this trend starts as early as kindergarten, with girls self-identifying as bad at math even though they have higher grades. A politically incorrect person might ask, well, why is it important that we increase the number of women in STEM anyways? Well, in the coming years, the majority of job growth will be in the areas of science and technology. For women to be financially independent, they need to be able to be competitive in this job market, because without financial independence, women are more vulnerable to abuse and poverty. So we have to change this trend. When I tried to pinpoint what exactly had sparked my interest in computer science, I arrived back at that summer camp I took in robotics. I didn't do any groundbreaking research in that camp. All I did was program a Lego Mindstorms robot to go through a maze. But my mantra in the coming years became, if I can program a robot to go through a maze, I can do this. When I learned recursion and kids were dropping from AP Computer Science like flies, I said to myself, if I can program a robot to go through a maze, I can do this. When learning machine learning, I said to myself, if I can make a robot go through a maze, I can learn neural networks. And then, if I can make a robot go through a maze, I can program a comprehensive drug discovery system to find drugs for diseases like cancer, tuberculosis, and Ebola. Okay, so that last one is probably a stretch. But adeptness with Lego robots doesn't guarantee bioinformatics breakthroughs. That's probably baseless. But the idea that girls can't succeed in computer science because of their personalities is equally baseless. And yet thousands of girls every year drop out of computer science because of this baseless misconception. Isn't my misconception that if you can program a Lego robot, you can do anything in computer science a much better one to teach young girls? With my nonprofit Litas for Girls, that's exactly what I set out to do. Through after-school meetings, I taught 40 middle school girls to program games, apps, and animations using beginner-friendly technologies like MIT App Inventor and Alice. At the end of the program, the girls designed their own app or game with some sort of real-world application. All was going well in LITAS until I saw one 9th grade girl who had some experience in robotics and programming dismiss herself as a non-technical person just because she made a small mistake in installing a program. That was the first signal to me that a different curriculum approach was not enough, that there was a deeper problem we needed to address here. And so I asked myself, what is that problem? Certainly a lot of the problem is that girls are encouraged by society to be much more critical of themselves than boys are, and constant self-criticism makes it extremely difficult to overcome the steep learning curves that come with a subject like computer science. But this isn't the only problem, because if it were, we would expect this red line right here to keep going up as society's attitudes towards women become more progressive. Instead, the number of women majoring in computer science peaked at 37% in 1984, and in 2011, that number was at 18%. So what happened in the 1980s? Well, the personal computer came into the home, which was theoretically supposed to make computing more accessible to everyone, but instead, the computer was mostly marketed to and bought by boys, so they were able to get early technological experience in the field and an advantage over girls who might have only been introduced to the field in college. And one trait I noticed while reading The Innovators this summer was that technological whizzes who we all admire, like Steve Jobs, Steve Wozniak, Bill Gates, they all started tinkering with computers and coding from middle school. And so that's why LITAS focuses on girls in middle school, helping to bridge the gender gap in STEM before that gap becomes a chasm. Personally, I learned to code right in the beginning of high school, but I think even my fun with Scooby-Doo PC games as a child gave me an easy familiarity with computers that was a prerequisite to doing more. In essence, Control-Alt-Delete built the foundation for Java error handling. And another thing we try to do in LITAS is start out each class with an example of a successful woman in technology, from Ada Lovelace to Grace Hopper to my personal role model, Elizabeth Holmes, who is revolutionizing the field of medical diagnostics with her company, Theranos. This is particularly important in the days when girls haven't had the time to get enough experience yet, because these role models, this media representation, shows you that your presence in a field is accepted, that you are not alone. Personally, my mother is a chemical engineer, and so the idea that women couldn't be successful in STEM was always preposterous to me. I was like, what are you talking about? Look at my mother. And so that's what we really try to do with LITAS. And after a while, I saw that it started to make a difference. The girls were enchanted by App Inventor. They began to show more confidence in their coding abilities. And at that point, I decided to make LITAS into a national nonprofit and take the insights I had learned to a larger audience. And so this past Labor Day weekend, we actually hosted our first technology showcase, where middle and high school girls from the greater Phoenix area were able to present their coding projects to judges from Intel, Avnet, GoDaddy, ASU Engineering, and many other companies. And we plan to hold many more such events throughout the year and really build a network for girls to learn computer science and code creatively. So the topic of this conference is finding your light. But I don't believe that each of us have only one light. I can think of 3 of mine that come to mind immediately: computer science, biology, and promoting women in STEM. Einstein discovered relativity, but he played Mozart when he couldn't solve a problem. But these various lights only become interesting when you weave them together into something unique, something only your vision and your experience could have created. In the course of your life, I've found that you'll come across many things that you enjoy. Don't abandon them in quest of some elusive subject that you'll love the most. And don't ever abandon them from a fear of failure or the thought that you can't succeed. Pick up the things that fascinate you and add them to your collection, like a painter adds beautiful paints to his palette. Let those paints mix and swirl and color your canvas. And then, when the time is right, hang up your painting for the world to see. Try to make this painting, your life's work, into something that will bring pride and joy to you and to everyone who sees it. Thank you.